Okay, so here's practice exam 1, step 3 note page. And this is going to take me more space than I've got here, so I'm using an extra sheet of paper also. So I'm just saying that because you might want to do the same. So, all right, let f be the function given by f of x is equal to natural log of x times sine of x. And this is the graph of f right here. The figure above shows the graph of f for x values from 0 to 2 pi. The function g is defined by this. So g of x equals the integral from 1 to x of f of t dt for the same x values. Okay, so the first thing that we want to do is find g of 1 and g prime of 1. And also, guys, I gave this last year and I noticed the same problem. I think people weren't sure what to call those numbers there. So this is 2 pi, and that right there is pi. So I think we should just label that real quick first. Because some of you later when you had to give an interval, I think you said from like 1 to 3 point something, or you said like from 1 to 3. And actually we know what this is exactly. That's pi. Because of this, because they're telling us this, so we know that's 2 pi. And that's like the halfway mark. Okay. So, all right, so first we're finding g of 1 and then g prime of 1. So this is for A. So let me first find g of 1. So this is the way that g works right here. So we've got the integral from 1 to 1 of f of t dt, all right? And always we need to ask ourselves, are we doing a limit, a derivative, or an antiderivative, or an integral? And for this specific one, we're looking at like really an integral, but like antiderivative slash integral, that's what this would fall under, that category. And you've got to remember that if you're doing the integral, which means the area under the curve, on an interval from 1 to 1, this is a 0 length interval. So you end up getting 0, okay? So I'll be like this. I'll be like, therefore, g of 1 equals 0, just so they don't miss it. They're going to be grading thousands of papers, the people who are grading your AP tests, so just make sure that they don't miss anything. And they have other people looking, you know, they have people checking, but really human error people make mistakes. So there's that. Now we need g prime of 1. All right, so for g prime of 1, so we ask ourselves the same question, limit, derivative, or antiderivative. This time we're doing a derivative. And then you have to ask yourself, well, what are my derivative techniques, especially, so particularly when dealing with a function that looks like this. If you take, all right, so let me go like this. Maybe I'll go like this right here. All right. So this is how you take the derivative, or the derivative of a function like this. You just take the input of the derivative is the input of the integral, but with this upper limit variable like put in there. So g prime of x is equal to f of x. So really, guys, when they told us that this was the graph of f, this is also, that's also the graph of g prime. So we're looking at a derivative graph there. So g prime of 1 is equal to f of 1, which is equal to, all right, so this is the graph of f, here's 1, that output is 0, equals 0. Therefore, and you don't have to do the therefores, I just think it's a nice touch. Okay, now on to and you got, let me look at the rubric. You got 2 points. All right, so those of you, you get 1 point for each of these. All right, so 1 point for each of those. Now for part B. On what intervals, if any, is G increasing? Justify your answer. Guys, whenever you hear like increasing or decreasing or anything about extrema, and then you go to this question, which we have it in our minds all the time, limit, derivative, antiderivative. So that has to do with the derivative of G. If we're trying to figure out and justify where G is increasing, we've got to be thinking about G prime. Okay, G prime. So for part B, you could maybe say to yourself that we need G prime of X greater than 0. All right, and this is, let me look for my, I want my salmon colored packet. Right here. Okay. Now, when we ask ourselves limit, derivative, or antiderivative, that's just supposed to like open up a door in our mind. And the door that, when we answer the question and we say derivative, G is increasing, you know, all those things should open up. The next door that should open up is Susan's table. All right. So I want to know when this function G is increasing. Well, in order to figure out where the original function is increasing, I need to know where its derivative is positive. All right. So that's why I needed this. Okay. Well, guys, so we need this, and then what do we know that's going to help us? We need this. We know that G prime of X is equal to F of X. All right. So this is G prime of X. And I want to know, like, where is it positive? And it is right here. And a lot of you tried to name this interval, but you said from 1 to about 3. And this value here is actually pi. So that's why I couldn't give you a point, although I wanted to. All right, so we need this. We know that. Therefore, G is increasing on the interval. And guys, I guess they want you to, so we're including the endpoints, and I notice that they always seem to include the endpoints when they're talking about increasing or decreasing. And you know, you might say to yourself, well, at these endpoints, the function is neither increasing nor decreasing because that's where the derivative is 0. But we could talk more about that in class. But I do understand, I personally do understand why they're including the endpoints. So let me save that for an in-class discussion. All right, but it's increasing on this interval because I'll say because G prime of X is greater than 0. And then I'll be like, because G prime of X is greater than 0 on the interval. Wait, why don't I say this? Increasing on this interval because G prime of X is greater than 0 between X equals 1 and X equals pi. Okay? So this right here would get 2 points, okay? You would get 1 point for the interval. 1 point just for saying the interval. The second point comes from everything else. Like, saying, like laying this out, that we need this, we know that, therefore, blah, 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 because this. Okay, so that would be the justification. All right, now, this here, for this interval, find the value of x at which g has an absolute minimum. Absolute minimum. Okay? So guys, when you hear about minimum, maximum, increasing, decreasing, any of that, limit, derivative, or antiderivative, derivative. All right? However, when you hear absolute minimum, you need to do something called, when you hear the word absolute, all right, this word absolute means you have to do what's called the candidates test. And this comes up a lot in the free response sections. And it is, and really guys, we need to be familiarizing ourselves with these packets. I'm looking right now through one of our yellow ones, or our salmon colored ones. I'm looking for the candidates test. I don't see it. Maybe it's in the other. It is. Okay. So it is in exam topics to look for part 2. And when I made these packets, I really, really tried to just focus on the things that I knew would benefit you. All right, so everything in this really we need to know. Okay, so the absolute extrema, here's an example of using the candidates test. So I don't have it written down, but you took notes on that, so you could look at that if you'd like. But basically, we've got to go like this. All right, so this is for part C, and this is where you might want an extra piece of paper. Okay, so candidates test, and then I'll go like this. All right, so it goes x, and then in this case, g of x. All right, so you do the input values, and then here you plug the input values. These will be the candidates for absolute extrema. And then these will be the outputs at those various candidates. And whichever output is the lowest, that is the absolute min. All right, so you put the endpoints. So the endpoints of our interval are 0 and 2 pi. So the endpoints go in there. And then, like in the rest of this space, we put the critical numbers where g prime is 0 or g prime is undefined. All right, so whatever this function is that we're trying to find the absolute max or min of, these numbers that go in between the endpoints are the critical numbers where this stuff is happening. Okay, so g prime of 0, or g prime is this graph here. So where is it 0? It's 0 at 1. It's never undefined. It's 0 at pi, and it's 0 at 2 pi. Oh, so it's really just those two. So 1 and pi. So 1 and pi. All right, so here go the endpoints, and then between them, we put the critical numbers. Okay, now for the outputs, so for this output, I've got to go g of 0. Okay, well, g of 0 is the integral from 1 to 0 of f of t dt. Okay? But guys, notice this is a backwards interval. So this is a thing that we maybe haven't done in a while. If you negate an integral, then you can flip the limits of integration. Okay? Now, we need to be asking ourselves, actually, let me go through and get them all, okay? Now, I can't actually, so, actually, let me go like this. So, it's this blue, it's that blue area that is the integral from 0 to 1 of f of t, but I'm negating it. So I can't really say what this blue area is. I don't know what it is. They're not giving me any information to really tell me what it is. Okay, but things I do know about this blue area. I know that it's negative. I know it's a negative area because it's below the x-axis. So I know that I'm negating a negative area. If you're negating a negative, that's a positive. So even though we can't say exactly what this number is, we can say that it's greater than 0. Okay, that's something that we can say. Okay, so now we're going to do g of 1. So g of 1 equals, and guys, you've really got to, they're going to give you things, they're going to ask you to use things that you've already found. So instead of going through and trying to find g of 1, it was part A that we had to find it. So we already know that that is 0. So that's equal to 0. All right, so far we've got a positive output for this x value. We've got a 0 output for this x value. Now we got to do 2 more. So this is g of pi, which is equal to the integral from 1 to pi f of t dt. Oh, and by the way, you know, this question that I keep coming back to because it is so very crucial for us, our success, limit derivative, antiderivative, like we had to use the derivative for the candidates test, but now we're using integrals. Areas under the curve is what we're using. Okay, so there's this, and let's look at the graph and see what we can say about it. All right, so this is from 1 to, so this is this pink area. Well, what can we say about it? What can we say about that pink area? All that we can say, really, is that it's positive. We could say that it's positive, and it's like, you know, it's bigger than this blue area, and it's positive. All right, so really all I can say is that this is greater than 0. And then, and by the way, this is the part of the test, like where really, like this is hard. I'm not trying to say that this is not difficult. This is very challenging, but you can absolutely do it. And we have a lot of training ahead of us. Okay, now last is this one. So I've got to go G. Okay, so actually so far, let me say this. So far out of all of these candidates for absolute minimum, it looks like this, if this ends up being another positive number, then the absolute minimum is going to occur at x equals 1, because these are both positive and that's 0. All right, so let's see. So of 2 pi equals the integral from 1 to 2 pi f of t dt. Okay, so I'm doing the area under the curve from 1 to 2 pi. So the pink area is part of it. And then I've got to add to it the yellow area. So actually, I'm going to split this integral up. I'm going to split it up from 1 to pi and then from pi to 2 pi. So equals the integral from 1 to pi plus from pi to 2 pi. Okay. Okay, now what can we say? Like, what judgment can we make about this sum here? it's the pink area plus the yellow area. The pink area is positive. Okay, so this is positive area. And then this is negative area. Not only is it a negative area, but it's a bigger area. Negative bigger area. The green part, the yellow part is outweighing the pink part. So you've got like a small positive number plus a bigger negative number. Okay? So the judgment that we can make is that this sum is greater than 0. That looks awful. You don't have to erase that, but I'll go like this. I'll say greater than 0. Greater than 0. Now we've got to justify greater than 0, and then because from looking at the areas on the graph, yeah, greater than 0, and then we'll just say by, sorry, I know people love when I erase. That's why we should all be using pencil. So greater than 0 by looking at the areas on the graph. Yeah, so just tell them, say a little something about how you know that. All right, so that's greater than 0. So, positive number, 0. Positive, no. This is less than 0. Ugh. I'm sorry. There's no way I'm making this video over. Shoot. Yeah, duh. That's what I meant. Less than 0 by looking at the areas on the graph. Okay. So positive number, 0, positive number, negative number. So the answer is, let's go back to the question. Find the value of x at which g has an absolute minimum. Justify your answer. Okay, so, and then we say g has an absolute minimum at x equals 2 pi. And then we'll say, we could be like, by the justification above. Because I already kind of laid it all out. So make sure that you tell, I don't know, your paper's going to have a lot of stuff on it, so make sure you tell them like where to find stuff. So G has an absolute minimum at this by the justification above. Okay, and then they'll be able to see candidates test, blah, 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 blah. Okay, now, part D. So, part D. Okay, and let me pause just for a second. Guys, A and B, you can get that. You absolutely can get that. That's 4 out of 9 points right there. And that's better than the national average. Okay, that's where we want to be. We want to be like just above average, and we can all get there. You absolutely can get there. And you're already well above average as far as humans go. So we can absolutely do this. So so all of you can get A and B. C and D I know are hard, but don't count yourself out. All right? Lots of training we're going to do. And okay, so for D. For this, is there a value of x at which the graph of G is tangent to the x-axis? Explain why or why not. All right. Well, guys, if you cannot, you should be able to visualize what they're talking about. Okay, so let me draw. Okay, so what does that look like? Tangent to the x-axis. All right, so let's say that that's the x-axis. What does it look like if the graph is tangent to the x-axis? It would look something like this, all right? Okay, now, what can we say about this point here? All right. What can we say about this point? We can say that the y coordinate equals 0, and we can say that the slope also equals 0. Those are the two things that we can say about that point. And this is just a sketch. And pretend that it's g, because they're asking us, is there a value of x at which the graph of g? All right. Well, what does that mean, guys? Y coordinate equals 0. That would mean g of x equals 0. And slope equals 0. All right. Slope equals 0. Limit, derivative, antiderivative, integral. If you hear the word slope, no. It doesn't mean that. If you hear the word slope, it's derivative. All right. So if the slope is 0, then g prime of x equals 0, which would mean in this case f. So guys, we're looking for a value where g of x is 0 and f of x is 0. So we're going to look at the picture. All right. Well, f of x, this is f, it's 0 at 1, 3, and 2 pi. Is there, okay, so out of all of those values, is there one that we know that g is 0 there? And actually it goes back to this very first thing that they asked us, and they'll do this a lot, where it'll just come back to the one of the very first things that they asked you. So g of 1 is 0, and f of 1 is 0, because this is the graph of f. Okay, we know g of 1 equals 0 and f of 1 equals 0. Therefore, okay, we know g of 1 equals 0 and f of 1 equals 0 and f of 1 is equal to g prime of 1, just to be clear. Okay, so we know that the derivative is 0. Okay, so we know this, therefore, yes, there is a value of x for which the graph, and I'm writing too much probably, is tangent to the x-axis, comma, and that value is x equals 1. Okay, I could have said that better. Okay, guys, so just like I said, you know, try your best to understand C and D, but do not beat yourself up if you're saying, I could never do that. Okay, because number one, that's not necessarily true. We're going to get you to be able to do a lot of these things, number one. But number two, not everyone is supposed to be able to get them. This is supposed to be super hard. But the A's and B's, you can do it. Okay, I'll talk to you later.